To drive a car in different speeds, the gearbox is necessary because the engine only has a small RPM range. In the next couple minutes we will show you what exactly happens when you change the gear with the shift shaft. We will explain this on a 6-speed manual transmission with a reverse gear. The first part is the input shaft, which receives the torque from the engine through the clutch. Below is the left side ball bearing of the countershaft. The next group is the synchronization unit from the 5th and the 6th gear. The gear near the input shaft connects the input with the countershaft. In the next group is the synchronization unit from the 3rd and the 4th gear. The upper shaft is the main shaft, the one below is the countershaft, in between is the stiffener. The next components are the torque transmission and the right side ball bearing of the countershaft. Afterwards comes the synchronization unit from the reverse gear with the reversed shaft. The last unit is the synchronization unit from the 2nd and the 1st gear. All orange gears can rotate freely because they are placed on bearings. Let's assume we are driving in the 1st gear and want to shift one gear up, but the 2nd gear's rotation speed differs from the main shaft. That's why we need something to adjust the speed of the 2nd gear, otherwise we will break the gearbox. To understand what exactly happens in the synchronization unit, we will use a simpler model assembly. First, have a closer look on the components which are necessary for a synchronization. In the explosion you see the 1st and the 2nd gear. Afterwards, in red, the synchronization rings and the needle bearings, followed by the shift sleeve and the synchronizer hub. The 3 centering units come up next, consisting of the locking ball pin, the strut and the spring. On the countershaft are the fixed 2nd and 1st gear. In this simulation the shift sleeve gets pushed to the right side, which is why the main shaft starts to rotate with the same speed as the 1st gear. More now in detail. The synchronization is structured in 5 phases. Before the shifting process, the shift sleeve is held in a neutral position from the centering unit. In the first phase, the synchronizer ring gets pushed from the strut against the clutch gear with cone. The synchronizer ring starts to turn, but not with the same speed as the 1st gear yet. When the inner claw toothing pushes against the synchronizer ring, they are blocked against each other and turn with the same speed. In this phase, the gear speeds get accelerated or decelerated. When all parts turn with the same speed, the synchronizer ring gets pushed a bit in radial direction by the shift sleeve, so they can mesh and then pushed against the clutch gear with cone. The shift sleeve pushes the clutch gear with cone a little bit in the radial direction and slides into it. In the last step, the shift sleeve gets pushed all the way to the 1st gear and finally connects the main shaft to the rotation of the 1st gear. Now that we know how the synchronization works, let's go back to the complete model. The difference now is that you can see the shifting claws in orange and the shifting mechanism in blue with the shift axis. The shift axis is moved in 2 ways. One is rotational movement, which you can see in orange, which changes the gear group. The other one is the translational movement highlighted in blue, which moves the shift sleeve into the selected gear. The 2 wires in green are used to get the movement from the shift shaft to the shift axis. How those 2 movements are generated will be explained in the next animation. Changing the gear within a group only moves the blue wire. Changing the gear group moves the red wire as visible in the animation. Now we want to see what is happening in the gearbox when we shift through all the gears from the 1st to the 6th gear. The highlighted parts in green are the parts which actually transfer the torque from the input to the output shaft through the gearbox. The difference in the 5th gear is that the input shaft is directly connected to the output shaft. The counter shaft is not in use. In the 5th gear, the output shaft rotates with the same speed as the engine. In the reverse gear unit you can see that there is an additional gear which causes the output shaft to turn in the opposite direction. We hope that we were able to improve your knowledge about the shifting and synchronization in the manual transmission of a car.
Tschüssle!